I'll give it to you. Probably tomorrow. All right. So, let's start over there, shall we? Actually, I might just move this guy. Let's go old school here. All right. So we're still talking about algebra methods or algebraic methods to solve limit problems. And as it turns out, it's sort of a nice review of everything we ever talked about in algebra, it seems like. Okay. So here's something that I know that we saw before. That is a plus b times a minus b. This will be a good review for Friday. Anybody know what that is off the top of their head? Close. A squared minus b squared. I think that's what we said. I just say a minus b squared. But
Yeah.
so it's, yeah, a squared minus b squared. These things right here are called conjugates. All right. And multiplying by the conjugate is normally just, you get the same term, but you put the opposite sign there in between. And where that comes into play and is helpful for us is in some limit problems that direct substitution doesn't work, okay? So consider this problem right here. The limit of the square root of x plus 1 minus 1 all over x as x approaches 0. Are we recording? I think we are. Am I in frame all the way over on this side? Good. All right. So let's try direct substitution. We have square root of 0 plus 1 minus 1 all over 0. Well, I don't even need to go any farther. Because, as we all know, division by 0, a little bit louder. I'm going to assume it's the masks there that are muffling your answers. It does not exist, right? Okay? So what we're going to do is we're going to do a little bit of manipulation here. So I'm just going to take this part right here and just kind of focus on that. And I'm going to massage it a little, do some trickery here with it. So I'm going to take that square root of x plus 1 minus 1 all over x. And I'm going to multiply it. If I can find the green one. By its conjugate. Square root of x plus 1 plus 1. All right, so notice that square root of x plus 1 right here, that's sort of like our a term, and the 1 over here is sort of like our b term. And so I'm multiplying by the conjugate. I'm just putting a plus right there instead of a minus, okay? Now the problem is that you can't just multiply something by another number because it's going to change the value. You take 5, multiply it by 3, you get 15. 5 and 15 aren't the same. All right, you take 5 and multiply it by 20, you get 100. 5 and 100 aren't the same thing. However, if I multiply this fraction by this fraction, guess what? Doesn't change the value. Right? Mitzi, do you remember that property? Anything divided by itself is? No.
Isn't it itself?
No. What is 5 divided by 5?
1. Oh, the 1.
All right. So, not sure. Just throw some basic numbers. So this is 1. Now, another recall moment. What is anything times 1? Now it's itself. Yeah. Okay. So when I say square root of x plus 1 minus 1 all over x times blah 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 x square root of x plus 1 plus 1 all over square root of x plus 1 plus 1, I'm going to change the way that it looks, but I'm not going to change its actual value. Okay. So that's why I'm going to continue to write it in black here. And say, why did you choose the conjugate? Well, I chose the conjugate because I now have an a minus b, a plus b situation. All right? And as we all know, a minus b times a plus b is going to be a squared minus b squared. All right? So now, a little side note, what is, well, I'll throw it here, the square root of x plus 1 squared? Minus 1 squared all over. Now this denominator is just kind of messy. It's just x times parentheses square root of x plus 1 close parentheses. It's not this computer, it's that computer. Someone's doing some YouTube updates. It's the only thing that sent me or notifications on that. All right, Robert. What is the square root of x plus 1 squared?
X plus 2.
He says x plus 1. Would y'all agree with that? Because you have the square root, and then you square it, you're back to where you started from in the beginning, right? And then we have minus 1. The denominator is just as it was. We're going to leave it as a kind of as a mess thing here. X parentheses square root x plus 1 close parentheses. Then if you look in the numerator, I have a plus 1 and a minus 1. Those go away completely, so I just have an x divided by x over square root x plus 1 plus 1. And now, if you will further notice, I have an x in the numerator, x in the denominator. Those will cancel out. Now when it cancels out, I still have a 1 here left over in the numerator. So don't make the mistake of just saying that all this is equal to the denominator. It's equal to 1 over square root x plus 1 plus 1. So much algebra review, right? We're remembering this property, remembering that property, remembering multiplying by the conjugates. We're remembering canceling, right? Okay? So all that to say that this is equal to this, which 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 is equal to that. So now I can rewrite that original problem as such. I'll write it there so I can see the next one. The limit of 1 over the square root of x plus 1 as x approaches 0. So that's, I've massaged the problem with algebra. I've reformed it. I've refashioned it. Okay, I've done some algebraic transitioning magic here. Actually, it's math magic. But anyway, will direct substitution work now? Let's try it. 1 over square root of 0 plus 1 plus 1. 0 plus 1 is 1, so square root of 1 plus 1. What's the square root of 1, ladies? What number times itself equals 1? The correct answer would be 1, which is itself in this case. So it's 1 over 1 plus 1. Pretty sure you all know that one. It's 2. So we have 1 half.
So that's what we're going to do for a problem.
That's you'll do something like that for the problems that are like that. Okay?
Thank you.
You bet. Let's find one that resembles that form, maybe in the odd. Let's look at number 15. The limit of x minus 2 over square root x plus 2 minus 2, of course, as x approaches 2. Now, we might be able to do some of this in our head, and the first question is, does direct substitution work? You should always ask yourself that question. Well, let's see here. If we plug in 2 in the numerator, we end up with a 0, but who cares? It's not that big of a deal. We have 0 in the numerator all the time. People try to divide 0 into different things, but the only problem is if we have 0 in the denominator. So put 2 right here, 2 plus 2 is
4,
square root of 4
2,
minus 2,
0.
and we're kind of in that same stuck position again. Okay?
Mhm.
So, yeah, on number 15, you're going to have to do that. So, let's see if we can at least get it started here. If I'm going to multiply it by something, these sort of problems are kind of interesting because when you see that square root, that's the thing that you need to do. You need to multiply it by the conjugate, okay? So you might be like, which one is the conjugate? Which one do you do, the x plus 2, or do you do the one with the square root symbol, okay? Because that's what's going to end up canceling out. All right? So the conjugate here would be square root of x plus 2 plus 2. Notice I'm putting the opposite sign, the plus rather than the minus, as it relates to those two terms, a minus b, a plus b. And then put the same thing over itself, x plus 2 plus 2. So it doesn't really matter if it's square roots in the numerator or denominator, our process is going to be the same. We're going to multiply by the conjugate, voila. Mitzi, since I sense a little concern on your part, I will have you walk us through some of these next steps.
Wait.
Okay? All right? Now, this one's a little bit different because I've got kind of a mess right there, x minus 2. But I'll make your life easy for you. I'll tell you right now, you don't need to FOIL any of these things, okay? So that numerator, we're just going to leave that in factored form. So I'm going to leave that as x minus 2, and I'm going to leave this as the square root of x plus 2 plus 2. Now the denominator, we also don't need to FOIL because the whole reason we're doing this is to get an a minus b, a plus b situation. And we'll remember from back over there, an a minus b times an a plus b is going to equal a squared minus b squared. So, let's see how good are you there, Mitzi. What is, if this is a, what is a squared?
Isn't it like, I don't want to be wrong.
Then you're in the wrong place. This is the place to try. And when you try, you're wrong sometimes.
Isn't it x squared? No, yeah, x. No, it'll be x plus 2? But, because it's getting out of it, right?
Mm-hmm.
Yeah, that's
Yep,
right.
you're right. If you were starting to say it'd be the square root of x plus 2 squared, I would also say you're right. Then keep going in your head and go through the next step, which is going to be to literally cancel those things out. Now that's the a squared. Now I'm going to put the minus, and then we're going to put the b squared. So, Kirsten, what's the b squared?
I don't know. I'm a little confused now. I got kind of lost.
Okay. So what if, instead of doing that, so we are at this step right here. When we look back at this one, did you see where I had an a minus b and an a plus b?
Mhm.
Okay, are you comfortable going from, like dealing with numbers and letters and applying a formula kind of in your head to be, we know that a minus b times a plus b, and this is a squared minus b squared. So we got all that, right?
Mhm.
So so if I say that this is my a, right, square root of x plus 2. So what if I do this? Square root of x plus 2 squared, that's a squared, minus b squared. B is 2, so b squared, I'll just put 2 squared just to kind of make it real obvious. Let's see if that step makes sense to you.
So, wouldn't it just be 4 if there's a squared right there?
What would it, the 2 here?
Yeah.
Yeah, 2 squared, yep, sure. If you are.
And then the other one, it would just cancel out the square root and the squared.
And so you think it would be x plus 2?
Yeah.
Yeah, you're right.
Okay.
You're not wrong on any of that stuff. So yep. That's what Mitzi had said. I had asked her, what is the a squared? And she said x plus 2, and I'm like, yeah, you're right. Because the a is the square root of x plus 2, and when you square a square root, then the square root goes away. So that's the a squared. And now I was asking you, what is the b squared term? And since we see that b is equal to 2, then b squared would be 4. If you had said 2 squared, or if you had said 4, I would have accepted that. So you good now? Sarah, are we good? If you give me a second, if you tell me the part, then I'll make sure you're good on it. You're just gonna tell me the part that you want. Would it be helpful for you if we actually did the square root of x plus 2 minus 2 times the square root of x plus 2 plus 2 and just FOILed it out at least once? Would that be helpful? Side problem, real quick, we're going to FOIL this, okay? So, first term, square root of x plus 2 times the square root of x plus 2. Outer terms, square root of x plus 2 times 2. Inner terms, square root of x plus 2 times a negative 2, so minus.
So with this formula, you're basically eliminating the whole FOIL process.
Well, because we know
Right.
that, yeah.
That is, yes.
So like, so instead of doing that whole process, you just square root it,
A and B.
and then A and B, you square root the A, and then you square root the B, which is the conjugate,
Mm-hmm.
right?
Mm-hmm.
So we just square rooting.
We're squaring both of them, okay?
Yeah.
Because what I want you to see is that this is the square root of x plus 2 times the square root of x plus 2, which is the square root of x plus 2 squared. This is plus square root of x plus 2 times 2 minus square root of x plus 2 times 2. So those cancel each other out, and here you have minus 4. And so this square root of x plus 2 squared is literally just x plus 2. Alright? So, what I'm also telling you is that this is going to work every time you have an a minus b and an a plus b situation. Alright? And it's always going to give you a squared minus b squared. The first thing squared minus the second thing squared. Okay? So that takes us to here. I'm gonna write the limit as x approaches 2 in front of that. Now we're ready to continue on. That numerator, which is in that factored form, I'm going to leave. X minus 2, square root of x plus 2 plus 2. The denominator, I see here I have an x plus 2 minus 4. I'm going to simplify that into an x minus 2, because 2 minus 4 is negative 2. Now I hear those gasps of realization. Kirsten, what do you notice is beautiful about this?
You can cancel out the x minus 2.
Yeah. In real life, it doesn't always work out super wonderfully, but smart mathematicians jerry-rig these problems up so that whenever you multiply by the conjugate, you're going to get something to cancel. So, you're welcome. So we have the limit as x approaches 2 of square root of x plus 2 plus 2. Now, will direct substitution work on this? You betcha. Square root of 2 plus 2 plus 2. So that's the square root of 4 plus 2. So that's 2 plus 2, which is 5.
Oh wait, 5. You can't do me like that.
She said, oh wait, you have 5.
Wait, Mr. God is ready.
Oh man.
God, you can't do me like that.
Alright. So, do we think that we're good, that we could possibly, y'all could take care of 16, 17, and 18 on your own?
Yeah.
Or at least try them tonight and come tomorrow with a question? Absolutely, I think so too. It's the same process every time. I've given you an example where the square root was in the numerator, and I've given an example where the square root's in the denominator, so you should be covered.
So what about 11 through 14?
Yeah, let's take care of 11 through 14. Good question. Now, before I do that, real quick, what if you do all sorts of this stuff and you get a nice number like 4 or 1/2, and you want to check your work. What would be a way that you could check your work on these? Robert? Make a graph. Could you not just type that into Desmos and see what happens as the x approaches 2? Absolutely. And then plug in 1.9, 1.99, 1.999, 2 point, and then plug in table 2.1, 2.01, 2.0, yeah. And could you just kind of squeeze it, see if what it's approaching? Absolutely. You might say, why are we doing that for these in the first place? Because I've already shown you how to do all the problems with the graphs, okay? My job is to show you the algebra, okay? Because, as I mentioned a few times before, we're gonna get to the part where all of these are gonna be algebraic expressions, okay? And we're gonna have to be able to do the algebra. We're gonna get to the part where you can't graph it because there isn't anything to graph, okay? And so, that's why. All right. The last problem type that we have thought I had a good example of this. So I'll just pick one of these guys. So what we're going to do is we're going to simplify these. That's pretty much it. We're going to use algebra. I don't know if in Algebra 2 you did simplifying of complex fractions, but the only real reason why you would ever learn such a thing is so that eventually in calculus you could be able to solve these type of problems. So let's look at number 13. The limit as x approaches 3 of x over it's a fraction of fractions, so you're going to make this bar really, really big. And then here, 1 over, so a little bit of a smaller fraction bar, negative 3 plus x plus 1/3. All right, now, will direct substitution work?
Possibly.
Maybe. I got a 3 in the numerator, that's a good sign, but it also again doesn't really matter. What really matters is the denominator. 1 over negative 3 plus 3 over 1/3. So when I do negative 3 plus 3, that ends up equaling 0. I have 1 over 0 fail, right? Doesn't work, okay? So what I need to do is I'm going to manipulate this fraction in such a way to try to get something that's really nice. Okay, so here we go. This is also a nice algebra review, which is why this lesson is kind of very helpful. All right, and that is what we're going to do is I'll put this up here. We're going to find a common denominator here in these two fractions, and then we're going to turn this into a single fraction, then we're going to turn this complex fraction into a single fraction. So here we go. Lots of stuff that we're going at from the beginning. The lowest common denominator, or out of these two fractions, if I want to combine fractions, is going to be negative 3 plus x times 3. So here we go. I've got x divided by 1 over negative 3 plus x. I'm going to multiply this term by whatever's missing. So multiply it by 3 over 3. And then I'm going to take the 1/3 and multiply it by whatever's missing to get that common denominator, which happens to be negative 3 plus x over negative 3 plus x. Hope you weren't sleeping when you did complex fraction reductions in algebra 2. So x divided by So a couple of things just to remember here. Number one, go back to the beginning. Can you add fractions when they have different denominators? No, you can't. Okay, I think we're all in agreement on that. Item 2 to remember. Anything divided by itself is 1. Okay? So I'm taking this multiplied by 1. Taking this multiplied by 1. Alright? Next. When you multiply a number by 1, are you changing its value? No, but you're just changing the way that it looks. So I'm going to change the way this looks, but I'm not going to actually change its value. Third thing to, or whatever, 20th thing to remember. When you're multiplying fractions, you multiply the numerators and you multiply the denominators, right? Okay? So 1 times 3 is 3. Negative 3 plus x times 3 is, well, I'll just leave that as negative 3 plus x times 3. I'm just going to leave that multiplied out. Plus, fraction over here, multiply straight across. 1 times negative 3 plus x is just going to be negative 3 plus x. And the denominator, multiplying straight across, is just going to be 3 times negative 3 plus x. Next up, keep that numerator the same, x over the big bar. Do y'all see that I have a common denominator here? Negative 3 plus x times 3, negative 3 plus x times 3. So now, if you remember, when you have two fractions that have the same denominator, you will just add or subtract, whatever you're doing, with the numerators. In this case, it's adding. So I'm going to have 3 from that numerator plus negative 3 plus x. All over that common denominator, which I'm going to write it as 3 times negative 3 plus x. Notice I've got this really big fraction bar right here, so that I know that this is the numerator of all numerators, and this is the denominator. Okay? Now within that denominator, I do have a fraction. X big divided by. So I have 3 plus negative 3. Well, that's nice that those just go away. And I just have a single x divided by 3 parentheses negative 3 plus x. And now we have yet another thing to remember, this one from our junior high days, of how we did stuff like this. So 1/2 divided by 3/4. Right? Do y'all remember when you had a fraction divided by a fraction? Do you remember what you did? Yep. Dividing turns out to be the same as multiplying by the reciprocal. Okay? So division is the same thing as multiplying by the reciprocal. So what if I had this? 1/2 divided by 3/4. The same thing. I could rewrite this as 1/2 times 4/3. Yes?
Mm-hmm.
That's exactly what I have here. Although in here, my numerator of all numerators is just simply x. So I have x, which is the numerator of all numerators, times, flip it, the reciprocal of the denominator. So 3 times negative 3 plus x all over x. Hey, what do you know? I've got a factor here in the numerator and a factor in the denominator. That's the same term. What does that mean? Cancel them out. So it's, it turns out to be 1/1 for that. So weirdly, this is called a complex fraction. A fraction with fractions, okay? That whole thing there, x over 1 over negative 3 plus x plus 1/3, can literally be written like this. The limit of 3 times negative 3 plus x. as x approaches 3. In other words, that right there is the same as this right there because we multiplied by 1, which is the same as this right here because we just did the fraction multiplication, which is the same as this right here because we combined the fractions, which is the same right as this right here because we simplified those terms, which is the same right here because we did fraction division is the same as multiplying by the reciprocal, and so therefore that equals this right here. Now, let's try direct substitution on this one. 3, open parentheses, negative 3 plus 3. And you're never going to believe what we get. What's negative 3 plus 3, class? And 3 times 0? Oh.
All for a 0.
So much fun. All for nothing.
Literally.
Just kidding. That was quite for something.
Can't see what argue otherwise.
So, all right. So are there any particular steps there that didn't make sense?
No.
No?
Not really.
All right. Now the question is, could you do something similar on those other 3 problems?
Technically, yes. Guess.
Let's look, now one of them isn't like the others, okay? So I think that, looking at 11, 12, and 13, 11, 14, I think 11 is a lot like 13, right?
Mm-hmm.
But I think that 12 is a little bit different, right?
Mm-hmm.
So let me get you started on 12 without giving away all the secrets, okay?
Mm-hmm.
I think we've got just enough time for that. Limit of 1 over, that looks a whole lot like the other one, doesn't it?
Yeah, that's just upside down.
It's upside down, so maybe we should do number 14.
I don't know.
1 over 1 plus x minus 1 as x approaches negative 1. I bet you can pretty quickly answer this question. Will direct substitution work? No,
Right,
because
not
plug in
that
negative 1 right there, you get 1
no.
plus negative 1, it gets a 0 right there, okay?
But
So, let's see if we can figure out what would be the lowest common denominator here. I'll write it as 1 plus x, that's what we've got right there. So, what I need to do is I need to combine this term, the 1 over 1 plus x, and the 1. Y'all see what I'm saying? The problem is I can't because they don't have the same denominator, okay? So, the process here of finding the lowest common denominator is literally what's the denominator on this one? So 1 plus x, and what's the denominator on this one? 1. Yeah, technically you think of it as like 1 over 1. So that's what I did back here on this one. When I said what's the lowest common denominator between these two, it's just this denominator times that denominator. Okay? And then I take whichever term is not present in that denominator and I multiply that term by itself. So in this case, since I had the negative 3 plus x, I multiplied it by 3 over 3. And in this one, where I had the 3, and the missing term was the negative 3 plus x, I multiplied this one by the negative 3 plus x over the negative 3 plus x. So, looking at this one, I would multiply this term right here by the thing that it doesn't have, which is 1. So it would be 1 over 1 minus, and then this term right here, I would multiply it, say this one makes sense, multiply that negative 1 by the part that's missing, which would be 1 plus x over 1 plus x. I feel like if you can do that, the rest of it, I think y'all can handle.
You multiply by each other.
I think you're saying something right. Say it again.
You multiply it by each other, like the.
Yes. You multiply by the denominator on the other guy. And because if you think about it, if this denominator is a, eyes up here real quick so you can see this is a little hand motion here. If this denominator is a and this denominator is b, what we really need is this to have ab and this one to have ab. Okay? So what you do is you multiply this guy by b, but you can't just multiply by b, it's going to be b over b. You multiply this one by a, but you can't just have a down here, you got to have a over a. That kind of,
So I can multiply, so I can divide and so it can be like it's 1, you know what I mean?
Got none
So
of that.
so is that
Oh, we're confusing it there.
exactly, yes, so that's why I said, yeah, that's why if you've got a in the denominator here and b in the denominator here, you multiply this one by b over b,
Yeah,
because of the reason of what you're referring to. Yep.
We got this.
I think you do too. Of course, everything changes once you walk out that door. I got a memory zapper on that frame, I think, it just helps you forget everything. You know what I'm talking about? This always feels like that. So anyway, I've got this homework slated to be due on Wednesday, okay? So that means tonight, you try to finish it all. And you walk in tomorrow with questions, okay? That's why I give 2 days. Now, the thing that also is due tomorrow is homework 2.4 and 2.5, okay? Sorry, not homework, but the notes on 2.4 and 2.5.
Okay.
The reason why I have both those combined is because we're gonna have just one homework assignment that deals with both of them.
Tomorrow.
That's when you walk in the door. Notes 2.4 and 2.5. You will, if y'all are on the classroom, this is one of those few classes where I was saying you face-to-face students do not really need to pay so much attention to the online Google Classroom postings, okay? Because the online Google Classroom postings are these things right here. That's where my virtual students are going to be taking the pictures and turning the pictures here in. You don't need to do that because you're just turning it in physically. So, all right, good talk. Let's go ahead and kill the video there.
I'm gonna say bye.
But you didn't say your
Your-
goodbye.
Did you hit it yet? Make sure you like and subscribe.